Here I am working on number 3 and number 4, where we have to graph these functions without using a calculator. The first one is in factored form and the second one is not. So these are done slightly different. Only really the beginning of the number 4 is going to be different and everything else will be the same as far as the process. So the first thing we need to do is find the zeros. So to find the zeros, we are going to set each factor without the exponent equal to 0. So this first one, we just look at 2x plus 3 equal to 0. We don't need to worry about the exponent until we talk about the behavior of the graph. When you have 2x plus 3 equal to 0, x is going to equal negative 3 halves. You subtract the 3 and then divide by 2. We also will have x plus 3 equals 0, which will give us x equal to negative 3. And for x minus 2 equal to 0, we will have x equal positive 2. And again, don't worry about the exponents right now. So I'm going to plot these. I'm going to make the graph here. So just try to be somewhat careful as far as making your marks on the graph here so that it is going to get fairly even as much as possible. Okay, so that's done. Good enough. All right, so negative 3 halves is negative 1.5. So I'm going to plot that graph right here. That's point right there. Negative 3 is over here, and positive 2. Okay? All right, so the next thing we need to do is figure out the end behavior. And the end behavior is determined by the degree of the polynomial. And when you have a polynomial that is in factored form, you have to add up all the exponents. We have a 2, we have an exponent of 1 here on the middle term, and 3. So 2 plus 1 plus 3 is 6. So the degree is 6. We also need to know the leading coefficient. The leading coefficient is any number that's out in the front of the parentheses over here, and then any number that is in front of the x's. So there's no number out in front, and the only number that we see that's in front of the x's is a 2, and so there's just the leading coefficient of 2, which is positive. So an even degree with a positive leading coefficient, both arrows are pointing in the same direction, pointing up in a positive direction. So that means this is coming up like that and up like that. All right, so I know my arrows are pointing up. Now I need to figure out what am I going to be doing as I go through the zeros here. At my negative 3 halves, I have an exponent of 2. Because I have an exponent of 2 and I'm already above the graph, I'm going to have a parabola type shape as I go through the point. So the point is like a vertex to the, I'm sorry, that's at the 3 halves. I need to think about that here. I was thinking at the negative 3 and I was above the graph, so I got to look at that. All right, so at the negative 3, my exponent was 1, so I'm going to be going straight down through that point there. So an exponent of 1 goes straight through, just like a line. Okay? Now I'm down below the x-axis, coming back up towards that negative 3 halves. We already determined that it's going to be a parabola type look at that point because of the exponent of 2. And so I'm down below, so that is actually going to be a parabola opening downward with the point kind of acting as the vertex. So it's going to come down like that. Okay, I don't know how far I'm going down here yet, so I'm just doing the behavior at the 0. And then at the 2, I have an exponent of 3. Well, that's going to give me an S-curve, and because I'm down below the x-axis, my s-curve is going to be kind of like that, where it goes upward. So I'm going to graph this so that it comes up and curves through a little bit. Just make sure that I see that it's curving so that I know that you did something as opposed to just going straight through. All right, now we need to test our y-intercept. So we can see how far down we go with that. We'll also test the value of -3 later, or -2 later. So the y-intercept is when x is equal to 0. So if I plug in 0, I get 2 times 0 plus 3 squared, and 0 plus 3 and 0 minus 2 to the third. Okay, well 2 times 0 is 0, plus 3 is 3, and 3 squared is 9. 0 plus 3 is 3, so 9 times 3. And that was 0 minus 2. It's pretty sloppy there, but 0 minus 2 is -2, and -2 to the third power is -8. Well, 9 times 3 times -8 is -216. Well, that obviously is not going to fit on this graph. So what we're going to do for the y-intercept is we're just going to go down like this and like that. And we're going to say y is equal to -216. So at least I show I understand that that goes way down there. All right, so let's try -2. If I plug in -2, that is 2 times -2 plus 3, and that is squared, times -2 plus 3 times -2 minus 2 to the third power. 2 times -2 is -4, and -4 plus 3 is -1. -1 squared is 1. -2 plus 3 is 1, so far 1 times 1. -2 times, -2 minus -2 is -4, and -4 to the third is -64. So again, that is off of our graph, but not quite as far as -216. So I'm going to go down here and show that that goes way down here and off the graph. And here I can somehow show that y equals -64. Okay, so that gives us a rough idea of what this graph is going to look like. All right, let's look at number 4. Here we have to factor this first, and what we need to realize is that there's an x in each of these terms, and in fact there's an x squared. So I'm going to factor out x squared, and when I factor that out, I get x squared minus 3x plus 2. And now I can factor this. I could either do the diamond method, or I could do quad 3 on the calculator, whatever method you need to do. So here I have x squared. When I factor x squared minus 3x plus 2, I will get x minus 2 and x minus 1. So now I have my I have three factors, and x squared is going to give me a 0 of the value 0. So x will be 0. For x minus 2, when I set that equal to 0, I will get x equals 2. And when I set x minus 1 equal to 0, I will get x equals 1. So here are my three zeros. I will go ahead and graph those. Again, be kind of careful and take your time putting the marks on. Unless you have graph paper, then that works out nicely, but I didn't give you any kind of graph on here to allow some flexibility with your graph. All right, so then I plot my zeros, 0, 1, and 2. Okay, these are really close together. I don't need to test the points in between. I'll just kind of stay fairly close. All right, by looking at the original polynomial, we know that the degree is 4 and the leading coefficient is 1. So just like So just like the other graph, it's an even degree with a positive leading coefficient. So my arrows are going to be going up, okay? And now if I look at the behavior of the zeros, at 0, my exponent was 2, so that's going to be kind of like a parabola. So this is going to be coming down, okay, and then up. And each of the other factors is linear, so it's the exponent of 1. So I'm just going to be going back down. I have to obviously curve back down, but as I go through the 0, it's a straight line. And then as I come back up through this 0, it's a straight line. And so my graph is going to look like kind of lopsided W. And I don't need to find a y-intercept here because I have a 0 on at the origin, so my y-intercept will be 0. And you could always plug in a half to see if this is going to go up really high or not. That's entirely up to you. I'm not asking for that, not when the zeros are this close. When there's some numbers in between the zeros, then I would like you to check the height or the depth of the graph, okay? And that's it for number 3 and 4.